Hi, everyone. Hi. Are you guys hearing me properly? Hello? Hello? Oh, okay, good. Okay. Thank you guys so much, for coming around for my workshop today. I believe like we're all IIoT enthusiasts, so I want to make sure that every one of you walk out of this room today at least, picking one information. So my workshop today is just basically a hands-on approach to configuring IIoT sensors to using what they call like the serverless framework. So one good thing about using the serverless framework is that you don't have to bother about managing servers. And we'll go ahead and give you a feel of how that could be accomplished. A little about me, I'm currently the full stack data scientist and principal at hybriData Solutions. We're a startup out of Los Angeles, California. Core of what we do is just mining value from data, be it leveraging artificial intelligence, leveraging industrial Internet of Things or big data. I had also have, as a matter of fact, where I developed the whole enthusiasm with regards to data was from the oil and gas industry. I worked as a reservoir engineer with ExxonMobil, and also I worked as a production engineer with Era Energy. So for the course outline today, first of all, I'll walk you guys through what the objectives for this course will be, give you a feel about just introduce setting concepts, just to familiarize setting concepts. Then again, I'll talk about the limitations and benefits of using the serverless computing framework. Then kind of touch a little bit about use cases currently in the oil and gas industry where we use IoT devices to get the data or do setting analysis. Then to the more fun part of the day, and we'll dive into the hands-on coding session. These are just the list below is just pretty much what we will walk through today. Then finally, we will walk through the IoT device data management, analytics, and exploration as well. So for the objectives of our course today, it's simply just for us to learn how to configure IoT sensors onto gateway devices. Gateway devices, I mean, since we're using a Raspberry Pi, we'll be serving like our gateway device. Also, we're also not just only configuring the sensors, but also ingest the data, telemetry data coming from the sensors, manage it, analyze it, search it, visualize it. All these are really what happens, in production for, let's say, any big IoT corporation you know about. I thought about not just giving you guys the hello world feel. I feel like sometimes the hello world, it's tough for people to move past the hello world, but give you a feel of what actually happens currently in production. So a little bit about IoT. IoT is just simply you using network connected devices. They could be like what we're doing today, we're doing with the gateway. We have like a gateway in terms of the Raspberry Pi. We have our devices. The sensors could be, appended to our devices. And also, there's also a different configuration where you have the networking component between inside an embedded device. So either case is still the same IoT type of system. Then now going about the technique we'll be using today to deploy these IoT solutions. So we'll be working with what they call the serverless computing model. The snapshot I have below is just giving you a feel of how IT infrastructures have evolved over time. So previously we had what they call the monolithic application, where you have all your database, your web applications, all running from one server. But now there's also what they call microservices. So microservices, if you guys are familiar with what they call the Docker, container computation platform. So with the Docker, or with the Docker, you can be able to segment, let's say, your web app, segment your database part, segment. You can actually even have like a mobile app extracting data from the same data service you have as a microservice. But what we'll be talking more today about is the function as a service model, which is the serverless module. So basically, you just, instead of having to manage each and every one of these microservices, now you just only have, hey, write your functions or write your codes and deploy it to the cloud. Obviously, with every good thing, there's always like a limitation. So some of the challenges about deploying or implementing the serverless computing model is its ability to handle big data computations. Because when you, let's say, when you get a serverless, when you reach out to a vendor to procure a serverless solution, the challenges are they give you like certain limitations, like how much memory the functions that you're writing has to, contain. What's like the computation time you have to, make sure you establish within that time frame. And also, at some point, for some organizations, using the functions as a service module might not be the best approach. The best approach might be going with a microservices approach. So for instance, the way we see like the functions as a service module, explaining it in terms of like oil and gas. So let's say you are doing like a walkover well that will take like 3 days. And you just want to, gather all the data quickly and push it to the cloud. You might not necessarily need like a microservices application. But let's say you want to, let's say, do like a drill well that takes you, be it like 30 days or 40 days. The amount of like network costs you're going to be incurring might be so large that when you look at it, getting people to manage those microservices architectures for you will be a lot cheaper. Again, you might be like an independent, producer. So maybe in a year you only drill like 3 wells. You look at the cost, it might still be better for you to go with serverless. But maybe if you're a huge producer, you're drilling like 100 wells or 10 wells. You look at the cost, and at some point it might not be viable for your business. Another challenge about it is in terms of like cloud provider lock-in. So once you procure a serverless solution, say be it from AWS, from GCP, Google Cloud Platform, or from Azure, Microsoft, or from Bluemix, IBM, or from other cloud providers, you are locked in to make use of those serverless services. Although currently there's what they call kubeless. I don't know if any one of you have had that. Has anyone heard about kubeless? Oh, you have. Awesome. So with kubeless, it runs under Kubernetes. But now you can actually procure functions as a service. But obviously, if you're running a Kubernetes cluster, it takes you back to the microservices model. But again, with the kubeless functions as a service, you can easily deploy the same functions that these cloud providers are providing to you. However, for the benefits, we have a lot of benefits. First of all, the little to negligible upfront investment. If you're like a startup like ours, or if you're like an independent producer that doesn't have like so many wells, you want to drill for so much amount of days, or you don't have like so many walkover jobs on your rig schedule or on your plan for the year. You want to move on with the serverless module in terms of it being little to negligible upfront investment. Another great thing is that you can quickly prototype. Faster time to market. You can execute quickly. Now, in terms of Capex versus Opex, running serverless computing model, you don't have to manage servers. You don't have to. So in terms of your costs can now be ascribed to like an Opex cost. And like I alluded earlier, you just only pay for the services you only use and you run. So use cases, I just kind of try to bring it down to what we're talking about today, energy domain based. So let's say you want to generate like a 4D seismic image of a target reservoir. So currently in the industry is being used, like we already have like IIoT devices being used. So you have like geophones to monitor the sounds, hydrophones if you're extracting the seismic signals from a marine environment. Also, you want to, I mean, if you want to do, currently I don't know what is being applied, but say for instance, you want to maybe control like how much vibration sounds from your vibration tugs, or how much pressure you use with regards to your air guns. These are things you can actually do with an IoT system. Then all, I mean, at the end of the day, what you're trying to do, you're trying to be able to what? See how you can estimate more likelihood of commercial hydrocarbon quantity. As far as reservoir production, drilling and facility engineering, IoT is everywhere. Reservoir surveillance. I remember when I was like a reservoir engineer, I get like permanent downhole gauges, pressure and temperature data, or wireline, you know, pressure and temperature data. I mean, then you analyze it, determine what's your reservoir pressure, then before they upload it into the database. But with IIoT, something that you can actually, you know, do now if you can get access to whatever network the IoT systems are. In terms of production optimization, so you're not just only optimizing based on like past data you got from operations personnel, but again, you can real-time do such production optimization. Facility capacity checks, you can do also facility capacity checks, monitoring your compressors, be your pumps, your motors. I mean, you want to bring certain wells on streams, you can be able to advise management on, you know, how they should go about with the help of IIoT systems. For pre-drill, while drilling, post-drilling analysis, we have like a lot of, you know, IoT systems, be it on your BHAs from top to bottom. So currently it's being used, you know, but another part is what I expect from this course is you being able to like, you know, go back beyond that way of, oh, you get only, I mean, you get the data you want. You can actually go in there, extract the data, query it, and extract more value from it. And now to the fun part. So this begins like the hands-on coding session. However, based on like the time we have right now, so what I thought about and based on Susan's suggestion it'll be a lot more better. I walk through the session. Walk through the session with you all, you know, because if you're not used to like be the serverless framework or AWS platform, it's going to be a lot challenging. If you're also used to like, you know, Unix systems, GitHub, and a lot of that. So I feel like the best thing is for me to walk you through it. Then now you can go back. I'll make sure I follow this same step that I listed out here. Then also, I'll also make sure I alert you on areas I had like problems with, errors in. That way, when you go back and you run it yourself, you can be able to like, oh, okay, he said this or he said that. So what I did first is this, because since we are deploying these solutions to the cloud, so first of all, I did the demo myself day before yesterday, and it all worked out well. But again, what I now did was I moved files, you know, different places, because my thought was, you know, we'll all walk through it here. But what I'm doing right now, as you can see on my terminal, is just me deploying the services, because sometimes this can take so much time for the services to be deployed. But good thing it all went through now. So based on that, I'll run through the presentation slides, and once we get to this point, I'll pull it up. Is that good? So back to the hands-on coding session. Great thing. I mean, a couple of you already have a Raspberry Pi. how to set it up. You flash your SD card with it. You download the operating system file. You use the etcher to wire, because since the OS is pretty large, so with the etcher tool, you can be able to, flash the operating system to a smaller size, file size. I didn't really encounter any problems going through this. So what you just needed, the key thing you need to pick out from here is just make sure, I'll recommend you connect your Raspberry Pi device through a monitor and a keyboard and a mouse. You might want to configure the device keyboard. This is pretty straightforward, and I never encountered any problems in this. But one key thing to note is connect your Raspberry Pi to the same network as the computer you want to be accessing the terminal from. So what I did this morning, if you had me earlier, I said like it was tough me being able to set up my Raspberry Pi system. But eventually, I was able to get my hotspot up, connected my laptop to it, then connected my Raspberry Pi to it. So your Raspberry Pi needs to be on the same network as the computer you'll be accessing it remotely from. So you want to make sure they're all on the same network. So once you set up your Raspberry Pi from the desktop and the keyboard system, the thing you want to do next is configure it, enable what they call SSH. So SSH, it just gives you the ability for you to be able to connect to the Raspberry Pi remotely. I never had any problems with this section, so it should be pretty straightforward for you guys. This is just basically for if you're using a Windows system, but there's a slide I added, the email I sent before the workshop, the first email I sent before the workshop, I kind of gave you guys a sense of if you have a Windows 10 device or a Windows 8 device, you should be able to set up, what the PuTTY will be doing for you. So, so this is still the same thing. Giving you a feel of how you can use a Windows PC to remotely connect to your Raspberry Pi device. Still for Windows 2 as well. So for this, it has to, if your operating system is running on the Raspbian Jessie, but currently, I think what I used for this was the Raspbian Stretch, which is what I pasted up there. So you don't necessarily need to go through all this. But if you're going to be using a Raspbian Jessie operating system, you might want to go through this step as well. So still, I never really had a problem with this, but this is just basically ensuring that there's no man-in-the-middle attack. In terms of configuring your Raspberry Pi device. Then I shared this with you about now for we to set up our serverless environment where we deploy these services to the cloud. You need to be able to configure sign up for AWS and configure your AWS CLI account. For Windows 2, those were the links I alluded to earlier that you can that you could use instead of using the PuTTY for that. Since we're now going into the serverless framework. So the serverless framework, you need to have what they call NPM. So NPM is just like a Node.js. Has anyone heard about Node.js here? Node.js? So Node.js is just, it's a back-end programming framework. I think it was developed by either Google or so, if I can remember. But it's a back-end programming language, but it's based off JavaScript. So for you to be able to, use the serverless framework, you have to like have the packet manager. It's just almost like pip in Python. So we know about pip, right? Pip in Python, PIP, the package manager for Python. So it's just about like, it's almost like pip, but it's NPM for Node, the Node.js and programming language. So once you install the NPM, which I shared the link with you, you can now be able to do what the NPM install. Then globally, you want to install your serverless framework using the command. So now you've been able to install your serverless framework. You want to configure your. So now if you have like a GCP account, so a Google Cloud Platform account, or if you, sure. So I'll just open it up. 1 second, I have California time on, so it's like 10:47. Just trying to check how we're doing on time. Okay, so nothing like, I mean, really that you have to do. So let's say you're using Mac OS, you just go here, you have to download the AWS CLI. Oh, you mean? Yeah, configure the credentials. So yeah. Yeah, just configure the credentials. Just like this, you hit AWS Configure, then you paste the credentials you generated from creating your IAM, user credentials, pretty much. You, we'll get to that though. That's to configure for you to be able to get the IoT data. Was that your question?
Right. I just want to make sure that there's nothing else that we have to configure the AWS account.
What we're configuring. So what we're configuring here is just for us to be able to have our AWS account ID as an environment variable. So now you choose, so first of all, it could be like you have a GCP account, right? So you want it to be like, hey, GCP knows that is CJ that's trying to push the data to, his cloud account, right? So basically, that's what you're doing. Since we're using AWS for this, so you're just configuring your AWS account. On the back end, making it an environment variable so that once you push it, it identifies, okay, CJ created this, and he's the one, pushing this data.
This just gives you access to rest, right?
Exactly, yeah.
We should probably use US East too, right?
US East 1. Yeah, US East 1 would be great. Yeah, I like using US East 1. And sure, keep the questions coming. Wherever you have, any questions, just make sure you, call my attention.
Like that, for example, that log is done in your CMD, in your command terminal, or is done something inside your account in AWS?
So first of all, right, in AWS, you create the account. Then they populate, they give you like the key, the access key ID and the secret access key, right? So now you go back on your on your terminal and type AWS configure, right? So once you type AWS configure, this is gonna pop up. This right here will just pop up. Then you impute your, what your access key ID is. Are we good on that? Okay.
That's in 3 places, right?
Yeah.
That's on your laptop, that's on your Raspberry Pi, and that's on AWS.
I will when I walk through it. But for this mainly, you just need it for your laptop. Yeah, not on your. You don't need that on your Raspberry Pi. Yeah, but there's something you'll be sending to your Raspberry Pi that will make AWS know that, hey, is this same person, that's communicating. Yeah. So yeah, I didn't have challenges in that, but obviously I have like, different like user configurations, but yeah, anywhere you have questions, feel free to chime in. So once we've configured the serverless framework with our AWS account, we just want to go do git clone. I assumed everyone, my bad, I assumed everyone had like a GitHub account already set up or a Git system already in place. So you do git clone for you to be able to get the repository for this workshop. So I'll go to, I already done that already. So I'm just gonna go to how it will look like. So once I do like git clone, 1 second. I'm just gonna try to open this in the top. So this is the repo for this workshop. So once you do like, you just come here. Well, I already, put that out there, git clone. That clones that repository for you. Then you go in and say cd. Cd is just a Linux Unix system command. Change directory to what you clone. Then, oh, my bad. So you change your directory to what you cloned. So as far as like these steps, yeah, I already, done this step though. But just to run through, so you're creating your keys and your certificate. So you need AWS. So going back to your question, so now for your Raspberry Pi device, right, you need to send your certificate, your private key and your public key to your Raspberry Pi device. So that's why I said once you run this command, it creates the certificate, the private and public key pair that you'll be using in your serverless configuration file and also your Raspberry Pi device. So then the next step is you copy the text value to IoT thing certificate. So I thought about, I'll just show you guys as I'll keep, 1 second. So I'll keep the slides like this. So in that way I can be able to, toggle to my IDE environment and you see like what I mean. So once you do this, run this AWS IoT, create this. But if you remember, when you copied the folder, you had like the AWS IoT configuration folder, and that's what I have right here, AWS IoT configuration folder. But when you, git clone, you wouldn't see any of this, but I've already generated this. So similarly, right, whatever step you took here, this step you took here will be what will export these values to the folder I showed earlier. So doing this step, I didn't really encounter any challenges or any problem.
So the IoT thing, cert arm, where is that?
Okay, so I'll show you that too. So it's right here. So if you see what I said, right, you're copying it to the IoT thing set ARN. My bad. So you're copying the value to the object in the IoT YAML file. So this is like the IoT YAML file where, I copied the certificate set ARN. So when you get this, like when you, download the GitHub, you're not going to see all this that I have here. You'll be the one that you have to provide them yourself. But you see like it's showing you where to put it in.
So in your case, that's 3 functions that you have right?
That's not function yet. So in the serverless, deploying like serverless application, you have to set up your configuration in what they call like YAML configuration. And to be honest with you, YAML configuration is not crazy. Forget about the name, but it's not crazy. And I mean, even the benefit of what you get, being able to look at the YAML file and understand it is, if any of you is conversant with Docker, right? What they call like Docker Compose, being able to like spin up different services. They use like YAML configuration patterns, but even like Kubernetes too. So you're even not just only learning about IoT system, but even being able to like do more other things. So, but I already set it up. You won't have to you don't have to write any YAML code. But like I alluded, is just give you like a feel of what actually goes on the production field. Then hopefully you're inspired to delve deeper and move further. So the next thing too is getting the root CA certificate. So I pasted a link where you can get the root CA certificate. I said move that root CA certificate to the AWS IoT. So if you see my deployment here already, you see that I have my root CA certificate here. So it's just the same thing you do and move it to there. So the next thing we now have to do is, so let me open the GitHub too. So if you go to the GitHub, you see the readdata.py file. So this endpoint right here, so for this endpoint right here, once you run this command from your CLI, you'll be able to generate the endpoint and replace it with with that spot on your readdata.py file. So once we're done with that, now since you're using the serverless framework to deploy those solutions, so you need something called like a package.json file for you to be able to for you to have your dependencies that you need in deploying the solution. So how to create that is on the same terminal, you do npm init. So it's just basically initializing, telling telling npm or node package manager that this is your project, your node project. Then accept all defaults. You don't need to change anything. Accept all defaults. Then install this serverless Python requirements package. I don't want you to think too much about what it is. What I want you to do is go through these steps and get a feel of the production environment, how it looks like in real life. Then now if you piggyback and you can now start, hey, what this is, but as we go along, I'll give you a feel of, what this is. So since we're using the serverless the serverless framework for this, and the serverless framework is on npm, right? So on the serverless, the main configuration file for the serverless project, they have what they call like plugins. Plugins is just basically, like the presenter gave us a little bit earlier, like the Lasio module, right? So this is just like a module that could interface with the serverless framework. But this module is, since we are extracting our IoT data from the sensors in Python, so this is almost like giving us, this is almost like, giving us a sense of feel of how we can package our Python packages and make it run on the serverless framework. So I already put that in here for you, so you don't really need to go go back. So it's not just only installing it. Once you install it, you need to come and put the plugins here. But I just didn't want to go into like a lot of that. So after that is done, we want to create like a virtual. Sure.
Third line, using that, what do you mean by that? You copy that and paste it somewhere, or the endpoints that?
You mean, oh, the endpoint? Yeah, the endpoint will come out like, let me show you. I think I just did that a while back. 1 second. So you can see the errors I got this morning just trying to run it.
So where do you copy paste it? Is it in one of the files that you
So
download from GitHub?
can you see this? So if you just do this, the endpoint comes up, and you can now copy this endpoint, and replace it there.
And this is just a command line?
Yeah, just on the command line. But obviously, you would have already set up your AWS, configured your AWS CLI account.
This is Python command line, right?
It's not Python, it's just Unix. It's just a bash command, since you're running it from the terminal. From PuTTY, once you SSH, right, you can now do that. Yeah.
So how do you do this? You do this in command on the Windows?
Yeah. On the command line on Windows too. Yeah.
So far, that's how we're doing is setting up the laptop, right? We have to copy AWS, we have
We're doing all of that in the command line. Yeah, all of that.
So on Windows, this would be done in PuTTY?
The what?
On Windows, this bash terminal?
Yeah, like on Windows, it's going to be like, let's say your PowerShell or your command prompt, But like, he was talking about, you can do that like with PuTTY. You can be able to like, SSH into, whatever instance you want to. And like I showed here, so if you have like a Windows 10, 1 second. So like if you have like a Windows 10, right, there's a way you can configure like, even the Linux type of terminal and use it from there. Or if you have even Windows 10 or less. Yeah. There's a lot of tools you can use to emulate the Linux environment on Windows.
So you can use Anaconda Palm, for instance.
Yeah, absolutely. Yeah. So right here, so once you grab the OS environment, so I'll try to run fast. We create an environment, pip install virtual env, pip install the requirements.txt file. We edit our .env file. We replace our account ID, provision our AWS cloud resources using SLS deploy v. So this was what I did last. So doing all that, you get all this, all this that I got here. You get to see all this that I saw here. And so now once we've done that, I already have my sensors configured to my Raspberry Pi right there, which for you, just similar, if you use the same type of sensors, your ground pin, your signal, or your data connection, you can easily the same thing here, mimic it. Then now once you set up your sensors, so I'll go back and log on now to my Pi. So my Raspberry Pi is already up. Oh, it went off, so I have to log in back. So I have this up already now. So once you have that up, you want to copy those folders, those configuration folders we created earlier to your Raspberry Pi device. So once you do that, that's when, if you look at my terminal here, right? So I copied the conf Oh, okay. I've not copied the configure. So you see me now copy it right in front of you. So right now, just go sudo. Oh, I have to do this on my local machine. So you have to do this on your local machine, not on your Raspberry Pi machine. So if I come here, since I already have this configuration folder here, right? So this is just the way I move this. I'll move this to my. I'll be moving this to my Raspberry Pi device now. Once I. Oh, lost connection. So 1 second. He wants me to. Yeah. Okay, let's see something. So he wants me to specify the. He wants me to specify the IP address. So I just go ahead. So let's do this. Come on.
You really haven't covered how you got the Pi on the Wi-Fi, but I assume we can figure that out.
Yeah, well, I mean, we'll talk about that, right? Oh, so there you go. So I'm just going to come right here. Come on. Whoa. What time? So I should expect this to go now. So I've moved it now to the Raspberry Pi device. So if you come here, previously we didn't have it here, but now we have it right here. Right here, right? So now, so once you do that, like, you know, I did, so this is just for if you're using Windows, you're still using like PuTTY for your SSH, you want to use the FileZilla approach. I mean, go to the FileZilla to be able to like move your files around. So now within our Raspberry Pi, we have to download the Aws Iot Python Sdk. Since we're writing our code in Python, they also have like SDKs for C++, for Java, for JavaScript, or Nodejs too as well. So if you're using any of those languages in configuring your sensors, but since we're using Python, we download it. So now we also, for our sensor device, or our DHT11 sensor, so typically, I mean, in production, the difference with this in production is that maybe you might have like, I mean, specially manufactured sensors from certain vendors, right? You want to get like the firmware to be able, I mean, firmware, and that way you can be able to access the ports of, I mean, the data ports, because that way you can, you know, stream the data. So for us, since we're doing, I mean, we're just, you know, using the DHT11 sensor, so we extract the Python package for it. So we CD into this folder, which I'll be doing right now with everyone.
So that sensor you got from, is that SZBZO, or what's the manufacturer name?
Just once you start the DHT11, yeah, if you search DHT11 sensor, yeah, you get the sensor. You can get it from Amazon, I believe. So once you've seeded into that, already I need to check what my read.py looks like. But so for you, my read.py, I just need to see if I already, like, you know, done the configurations already. So I do nano. Good, good. Okay. Okay, good. Interesting. Yeah, okay, but yeah. So I just saw something. I think I still had the AWS IoT configuration folder on my DHT file, but let's just go ahead. So since I've already configured, so now you come just like, you change this, the IoT endpoint, the broker address, then you specify the full part of the certificate, which if you look at what you download from the GitHub file, so you can see how I specified the full. So this is like an area I had literally I spent 2 hours trying to understand. So previously when I had done a prototype on a Raspberry Pi system, I didn't have to specify the full endpoint, but yeah, watch out for that. Make sure you specify the full endpoint for that. So once that is done, you just run read-up. So I'll go back to the services, right, to explain before I run the Python read.py. So so if you look at this here, right? So this is when I ran the serverless. So you can see the serverless deploy command that I ran, right? So what this is doing is, first of all, serverless checks for, hey, is this guy, and since you indicated that it's AWS that you want to deploy to, it checks, hey, does this guy have an AWS CLI already configured that I can get in information? Yes. Then it installs all the different packages you recommend. So now Amazon on the back end starts forming, the different services you requested. So this log files you can see here is what it gives you a sense of feel of the different things that we had formed from running that command. You're creating your AWS IoT system. You're creating, since we're using Elasticsearch, you're creating your Elasticsearch domain, your different AIM policies, your topic rule, and all of that. So since we've been able to create all of that, even with our CLI account, AWS CLI account, now we can go in right here to say, and since we have, more importantly, since we have that broker address. So since we have, one second. Yes, so since we've already set up this broker address, and we've copied the configuration files, the private key, the public key, and the root CA. So now AWS, if we say Python read data.py, AWS checks for your digital certificates, your public key, your certificates to be sure that, hey, this is actually the same person performing the command. And let's run this, and hopefully it works. Because I've not run it today, but so let's see what it gives us. Oh, okay. Wow, it's pretty smooth. So now we're getting data, local data from our sensor, from the Raspberry Pi. It's streaming already. I try to, like I said, make this, just kind of give you a really full solution, high level, and when you go back, you can go back and dig deeper to, looking at the Python codes that you all have access to, looking at everything, like how it came about. So now we're streaming data based off, this, script we have here already, right? So so this is where, so read data, your telemetry data should start streaming. So some of the challenges I had at this step is, one, your sensors might not be connected to the actual pins. So when you run this and it's not, producing streaming data, go back and look at your hardware device. Make sure like you're connecting the pins of the sensors to the right pins of the Raspberry Pi device. And once that is done, I always like to go into my account and just check to see. So some of the things we did here is, so if you look at the IoT stack YAML file, right? If you look at over here, we configured this DynamoDB table. And that's what they call like IoT rule. So like for AWS IoT, they have what they call topic rules. So we wrote a rule to, once our sensor data comes into the MQTT broker, it should publish data to our DynamoDB instance. The same too, since we are later going to be working with Elasticsearch too, we wrote a rule here too to automate that process to push the data from the broker to our Elasticsearch node. So that's just kind of like, on the back end, what we did and what typically goes on in production. So once
So all this is stored in DynamoDB on AWS.
on AWS, yeah.
And the laptop's not needed at this point, so you want to query it.
Pardon?
So you don't need a laptop or anything, so you want to query it.
You don't need what? I didn't hear you
You
clearly.
need laptop access. You're not streaming data as a broker directly to a
Yeah.
laptop. You're just going to the database and that's the repository.
Exactly, on the cloud. Yeah. So once that is done, trying to move fast. So once that is done, so now it's the part of we configuring, excuse me, 1 second. So once that is done, it's now the part of we configuring our Elasticsearch node. So really, Elasticsearch node is, for every business, big scale business, it's very, very important. So what Elasticsearch does for you is, for your IoT device, now you push all the different IoT devices into it. You can be able to quickly query the data. You can be able to quickly do analytics of the data. You can even be able to security see hey, what are anomalies going on with regards to your IoT system. But even the application of Elasticsearch goes beyond IoT system. But these are some things, I'm pushing it out for you all to see what is possible and on production level. The funny thing is that there's another way we could do this using the AWS. So AWS IoT service has what they call AWS device management. To be honest with you, on the back end, they're actually spinning up Elasticsearch clusters to host that solution. But if you want to be able to save some costs and expand your skill set, you want to move down to the open source tools, which is Elasticsearch. So here is just we trying to configure our Elasticsearch instance. So now I'm going to go to my local device. So now it's where the function you talked about comes up. So here we have this file here. It's just a function that we want to be able to invoke. Invoking it, by invoking it, we can create. So why we're invoking this function is that for you to set up an Elasticsearch node or cluster, you've already created what they call mapping data. You've already mapped your different data. So we've mapped I mean, it's just like creating, when you go about creating your database, right? Creating like different metadata. So we've created, the different data we expect from our sensor device. So I'll run this now and let's see. Oh, already exists. So, but I actually forgot to do source.env. Okay, good. Yeah, but what it tells us, like the resource already exists, so it has already created that index for us. If you go to like your AWS console, so you have this. Yeah. So if you come here, you see like the index, this index that we were trying to create. Already, it's even like streaming data already to the Elasticsearch instance. So once that is done, I already have this installed on my system, but if you have like a Mac system, you want to install this. If you have like a Windows system, you want to install it here. Because what happens is when you're creating an Elasticsearch instance in AWS, and you're defining your, what they call like policies. So in your access policies, if you see my access policies here, my access policies, it doesn't have, so normally you're meant to like tell the Elasticsearch node to stream data to a particular, through a particular IP address. But just for us to, avoid going through that way, using this AWS ES proxy 2 package, what it does for you is it just generates a proxy server that, again, it also makes sure that it takes your AWS IAM credentials, which we'll be exporting now, because if we don't export it, it doesn't know how it's going to be able, it needs an AWS account to be able to create that proxy, and that way you can interact with your node. So I already have that installed, so I don't need to do that. So now I need to export my AWS access key ID and all that. So you guys will have to close your eyes for a second while I do that. What happened? Okay, there you go. So yeah, so let me just export it real quick now. So,
those environment variables are on your laptop.
yeah, they're on my laptop. So I'm going to get it. So if you're using a Mac,
Make sure I understand what.
yeah, they're on your laptop. So those are actually those. You remember when I was showing you copying like the access ID? Yeah, that's it, and the secret key. Yeah.
So because you're running a proxy on your laptop,
Mm-hmm.
you should basically maintain just update it with the new data.
Sure.
And that just keeps growing.
Because that's happening in the cloud, not locally. And this is pushing it to,
So if I turned off my laptop, I went off and came back, it's going to want to update all that data as soon as I hit a first get, right?
it would, it's already is up, as long as your IoT device, right, is on, and you've done that initial initiation, it's already like, pushing the data to Elasticsearch cluster.
Running on AWS.
Yeah, exactly. Yeah, it's running on AWS. Say virtual MV. Source was a AAPG. Okay, good. So, got that. I'm almost there. 1 second. I'll be right there now. Good. Good. So good. Okay, cool. Okay. Back. So good. So pretty much what I did earlier, what I did for the 2 minutes ago was just exporting my AWS Access Key ID. So, what you just have to impute here would just be this, but you also have to copy everything. The same thing for your secret key. So now we want to get our Elasticsearch domain URL. Since in that way now we can now use it with the AWS ES proxy. So I would do echo endpoint now. What? Okay, so I probably didn't do source E and V. So now we have our endpoint here. So if you notice, because I didn't source the file where the endpoint is coming from. So you have to source it, that way you can, get the full endpoint value. So once that has been done, I'll just do the same thing here. And I copy this endpoint right over here. So, and that comes up. So it tells us localhost. So to browse through it, we just go here. So before we do that too, I like creating two. Oh, let's see where that happened. Okay, so we'll just go to localhost and get it out. So localhost 9200. So you get something like this. But if you look at this, you navigate to your browser, you paste that. But now for us to be able to get into this Kibana environment to visualize our data that we've been streaming now, we have to now, call in the Kibana plugin. So once we do / let's go plugin, Kibana. So now we'll hit discover just to be sure the data is streaming. So it seems like, we have some data streaming in. You can read our index. So so once we get to here, we come to here, put in IoT data. Next step, access the time pattern, created that. Okay, we'll go created that, create the index button. So the data we created is streaming to our, the IoT data is streaming to our Elasticsearch node. So now we, so now we set up like we visualize just to get a sense of feel, explore the data, see the chart. We can do a lot of host of different things off the Kibana and off Elasticsearch. But for the purpose of this presentation, so select the line chart, just like I have all that explained. So y-axis, average, field. You can choose any one. Add metrics, one. Average aggregation, field, temperature.
So does that sensor have both humidity and
Temperature, yeah. So previously I was looking for like a sensor that had like temperature and pressure. I mean, in terms of like, oil and gas, workflow, mostly temperature and pressure, but unfortunately I wasn't able to find one. But one thing, I mean, like I alluded earlier, the most challenge is not, connecting the sensors. I mean, the more challenge is being able to integrate get the sensors to push data, communicate with, the sensors. That's like, the most challenge.
And there's no time series issues here. Say I have 3,000 sensors, all have their own sampling intervals.
Yeah.
It doesn't care.
It doesn't care. As long as you're using like the Elasticsearch now, any amount. So for this though, what we deployed is like a node, just one single instance. But in production, you might want to, not that you might, definitely you'll be deploying clusters of, computers. But I mean, it doesn't, you don't have to like do so much. So only way you would perform any edits is just on your IoT, I'm trying to get this. On your IoT stack YML here, you configured your Elasticsearch instance. So you see the instance count just one. So you want to do certain things. Since you're also using a cluster, you want to change your zone awareness so that your main cluster can pick up, where the other nodes are. So it's just gonna be like simple changing, the amount of instances you need. So once that is done, say date histogram. So go we create date auto. So let's see. Yeah, it worked. So at the end so you can see the data has been, okay, it just showed us like, but if we say, let's say we want it to be maybe last 30 minutes. So for last 30 minutes, the humidity in Houston is about like 40%. Average temperature, this is in degrees Celsius though. But it's just simple configuration, something you can, from your Python code here, your IoT Python code, you can do the conversion from your read data, you can do the conversion right here to convert it to like, Fahrenheit if you want to. But this is all reading the data in degrees Celsius. So, and this pretty much it. So this was when I ran the demo myself. I streamed it for like 2 hours, and also I streamed it again for like, after 4 hours, and the chat it produced. And that's pretty much all of it. But obviously, once you're done with that, since you're not like productionizing it, you want to delete all the different resources so AWS doesn't charge you, right? Or even if they charge you at the end of they charge you maybe like $5 or less than that. So you want to, delete everything. So this is just we deleting the different services, how we delete it. So on a separate terminal, the first thing you want to do is you want to delete the So you want to delete the data from the Elasticsearch clause, Elasticsearch node. You guys want me to run through that? Oh, okay.
Is there a way to export out of the AWS database
Mm-hmm.
all of your data?
Yeah.
That you have that cache?
Mm-hmm. You can. Only what you need to do is, as a matter of fact, you can just write a function. So we didn't go into like, the serverless framework, right? So you can actually just write a function here. It's just like this function we have here. Write a function. First of all, obviously your function will go what? It will need your AWS account ID and your AWS, secret key. Then you have the DynamoDB API, right? You call the DynamoDB, you recommend the table, what fields you want, then you tell it, hey, push it to be my SQL server, be it to, wherever you want it, be it to CSV file. Hopefully your computer can take all the CSV files. But yes, or if you want to push it to, let's say you want to push it to a GCP bucket, storage, yeah. So you can, just write a function and it will go there. It will go right there. Yeah. So that's, so you guys want me to delete it? I can delete it. So, you see how you can also do it as well. Only the challenge I had about deleting it was, after you've deleted the index, you've run the serverless remove command, or make sure you navigate. So DynamoDB doesn't delete automatically. You have to navigate back to your console here and manually delete the table yourself. If not, but you have to do it after you've called this command above.
So if DynamoDB is a SQL database, can you just mirror it?
If it's what?
SQL database, can't you just mirror it to your own machine?
You mean what do you mean by mirror it? You mean access it locally?
Yeah, just basically pull the data off,
Mm-hmm.
database communications, pull
Mm-hmm.
the data off, and then have it delete the other data.
You can do it. You can do it. You can do it, of course. Since you already have your AWS CLI account set up, so what you need to do is going to be, the command is going to be maybe something like AWS DynamoDB delete table. But make sure it's the same account you used in creating it. So you can do that, Yeah, you can do that. Good.
One last question.
Sure.
How do you deploy these little guys in an explosive proof case?
Well, the thing is this, right? These little guys, depending on how you want to prototype it, right? Obviously, for setting oil and gas environment, right? So you need to source for, manufacturers, like sensor manufacturers, specialized sensor manufacturers, and also even creating the board, custom boards, But this is just, giving you, you having, before going to those manufacturers, right? You prototype, say, a temperature pressure solution, right? It's just easy. You're speaking to someone who, design the boards for you. What kind of sensors? What temperature do you want it to withstand? It comes, pretty easily. Yeah. But the funny thing is that, for, let's say, if it's not let's say now you're monitoring a wellhead monitoring, right? That you don't have to insert something, right? Into huge temperature or pressure. You can actually use this Raspberry Pi, for, monitoring your wellhead, as long as you have, not these sensors, but you have, the sophisticated, sensors, pressure and temperature sensors to do that for you. Yeah. And any other sensor, be you want to integrate be it your accelerometer sensors, you know, your vibration, pull up vibration sensors, you can do that as well. Yeah.
How much did that session cost you in AWS credits?
Honestly, I didn't really check, but I can assure you that it's not up to. So the thing is this, right? Depending on how long you want this guy to be streaming data to the AWS platform, right? So first of all, is that you have to quickly. So if you don't want to incur costs, you want to immediately you provision your Elasticsearch node. Again, that's why for this session I just use like one, even very little T2 micro system, right? But you want to immediately you provision it. You don't want to leave it sitting there. You want to immediately, get the sensors up, and working. But I don't expect it to be, more than like maybe $10. If you run it for, let's say, like maybe 4 hours, I might be overestimating it. So it might be like really like, that cheap, But yeah.
Does it give you limits that you can cut it off? Do not spend more than $10 no matter what.
It does. You can even write like a code to say, hey, whenever it gets to the bill is this, but I'll say not get into that now. Yeah. Even you can even write a code to tell it bill somebody else. So it's just like, bill somebody else, not me, Yeah. Sure. Huh? So let me just go ahead and show you guys how I will remove it. Is that okay? More questions, just, keep on asking. But one thing I want to point out is this, right, to be honest, is I am really big on IIoT. And for me, right, I think for you, it depends on how you see IIoT. But IIoT is beyond just oil and gas. It depends on what you see. So like self-driving cars is actually IIoT. You're streaming like sensors from your radar, your LiDAR sensors, you're controlling it, be like, different things. So it's just beyond just, so even your camera, so you want to extract images real time. The Raspberry Pi device has like the camera you can put in like to get images. You can also even have your algorithms, your machine learning algorithms ingrained, to act on whatever you wanted to act. Even, I didn't go into like the part of edge computation. So you can even do edge computation with this, but what you can do, and I see that, the way I see like, the next step is more or less like, you want to be acting on your data as fast as possible. So, and I see like, what you gain from this, hopefully you gain something from this course, to go back with. But it's beyond even like, just typical sensors. We just only went about monitoring and recording the data. We didn't even talk about like controlling. So if you want to control, if you look at this code base right here, so if you go to even the read data part, so you see here it says publish. So publish is just that, publish this data for me. So if you want to control, you have like a topic where it's subscribing to whatever you want it to do. Let's be shut off the wellhead. But what I can say, if you can be able to run through this smoothly, the subscribing part wouldn't be, it would be easier for you. Controlling part, integrating the edge computation piece to it will also be, much easier. And so now we have this for almost, it's been for 30 minutes now. Try to see for 1 hour. Oh, okay. It didn't get up to 1 hour, but. But that's kind of you know. So I'll just, show you how I will delete all the cloud resources and how you should do it. So on a separate terminal, I've already done the, yeah. So on a separate terminal, I've already done this source. I've already activated the Python environment, done the source, just checking, env. I've done that. So I've already exported I didn't want to do this again, so I already exported my AWS credentials. So now, one second. So first thing you do, right, you stop your IoT device from streaming data to the cloud. So I go to my IoT device, here it's just streaming data. So I do like Control-C to shut it off. So I cut it off now. So since I cut it off now, I can now go, since I already created an Elasticsearch instance, I want to delete all the data off my Elasticsearch instance. So that's also why the AWS proxy is good for you, because you can just go now localhost and delete all. So again, you don't have to shut this down yet. So you have to leave it on. So can you see this generated fresh AWS credentials object? So this was the AWS ES proxy getting my credentials. So now you don't need to shut this down yet, shut the instance yet. You have to navigate to a different terminal. After you've done all this and exported this, to paste in that call x delete. Oh. Stop that. Protocol. Oh, HTTPS. Let's do that. Oh, okay. I think I should have just wrote this myself. Let's see. Call. So I went here and copied and paste. So you want to, if you have encountered that problem, you want to just go back, type it in. So now it says that's been deleted. So now I can go to my I can now shut off my instance here, since it has deleted the data and the index. So just the same thing, I do like a Control-C to shut it off. So once I've done that, now I just do a serverless remove, just to remove all my AWS instances, all my AWS cloud resources. So it's getting all the objects from S3 bucket. It's removing my stock. And like I alluded earlier, although we could, do that from the console, but you can even search for it. So it's still deleting like the cloud resources we procured earlier. So you can see this being deleted too as well. It's telling us like, the Elasticsearch instance. So another thing I do, so if you go to your cloud formation, so what we did was we did what they call like, we just formed like, different resources from what they call the cloud formation on AWS. So you can see here, it tells you like, delete in progress. It gives you like more information. So pretty much what the serverless framework does, it just goes back end to extract like all these log files and sends it to us. So it's still deleting. So we created like the thing file. So once that is done, I mean, I'll just navigate to my DynamoDB console and delete it, and we're all done. While we wait for it, if you have any questions, and hopefully you learned one thing or two from my presentation today.
So when we go home and do this, are you going to provide your personal cell number we can call?
Well, I mean, I can say if you can do it completely within 2 weeks, I mean, I can provide my email address. You know, if you can do it within 2 weeks, then only 3 questions per person. So you want to try as much as possible. You know, I mean, make friends here. It's always good, you know, working in pair, because this person is gonna, I mean, provide this advice to certain people. I'll say, make friends. You guys work it together, and yeah, 3 questions per person within 2 weeks. I can be able to answer that. You know. Sure. Mm-hmm. It's right here. It's right here. I mean, this morning I had to even like, you know, configure it. I mean, configure it here. Configure it, I mean, I already downloaded the OS image, but configure it to make it, to connect it to my hotspot on my iPod and also my laptop for both of them to work. So it's right here though. And the sensor too is right here too as well, if you want to take a look at it too as well. Yeah. So it's sensing the temperature and the humidity in this room. Yeah.
Do you have any recommendations on minimum AWS programming or concepts
Mm-hmm.
sort of embark on this in a more conceptual manner? Because right now you're sort of following
Mm.
steps exactly, but
Mm.
to be able to understand what is this client doing.
You know the truth, right? So I try to, I mean, I try to, the way I take, the approach I take in like, you know, writing software code is not starting from, I always like starting from like, you know, the big picture. Because I think what happens is if you start from like the ABC, just get into the big picture looks like, hey, it's not possible. So what I did here, to be honest with you, we learned a ton of things. The serverless framework, YAML, Python programming, Nodejs, setting up your Nodejs files, AWS system, Elasticsearch and Kibana, huge big data framework. It's just, so once you dive in, once you follow the steps, believe you me, I mean, you gain like, I mean, you see what you can do, and what you now start doing is, okay, what's AWS IAM? What's AWS IoT? I didn't even talk about like AWS IoT structure, because I mean that could like, you know, take more time explaining it. But once you like get into it, you can now, hey, why was this? Why did I say, I mean, get this endpoint address? Oh, okay, this is an MQTT broker. Oh, okay, we need this MQTT broker for us to be able to talk to our AWS services. Why do we do this? So I would say, you know, once you get into it, once you search any of this online, you see like, you know, a good amount of information. And I have like references here too, you know, that I put up here. But I would say, answering your question, it just depends on, you know, how much you want to, I mean, learn about the AWS framework. You can learn little, you can learn big, yeah. But again, it doesn't happen like quickly, you know. But obviously, you just have to be like, you know, enthusiastic about IIoT or about the platform, yeah. So it's still deleting. So that's why I initially deployed it, because it takes, you know, ton amount of time. I don't know whether because of maybe the amount of resources we're trying to deploy to the cloud, or also the network connection that I have on my on the hotspot net, because now I'm connecting my laptop and also connecting the Raspberry Pi. But yeah, sometimes it could take this amount of time to deploy your resources. But yeah, as we can see, saying deleting in progress, that means everything is functioning well. Delete complete. You see like green, light. So you see the sensor, right? Yeah, exactly. And I think we finished in good time. And finally, I have like a survey for you all here to help me fill. Just tell me what you think. And here's my email too as well. Like I said, 2 weeks time frame, 3 questions from each person. Don't swap your emails. So I don't know you asked 3 times, but I'll say, make friends with people out here in the workshop. That way you get to the point where you can, you use your 3 questions, right, best. So sure, if you help me fill out the survey, that'll be great. Just so I know, how what you think about this course. And let's see if, it's you deleting. And that's pretty much all it from me. Thank you. Thanks. Let's see, hopefully he stops. Yeah.
Thank you, CJ. That was really great.
Absolutely.
Really
Pleasure.
appreciate it.
My
And
pleasure.
it's really generous of you to agree to answer people's questions. That's a huge help. Really helpful.
Sure.
So I wanted to talk again.
Sure. My pleasure. Sure. My pleasure. It's a pleasure. It's right there. Yeah. As a sensor. Yeah. So you can actually send the device.
And this could be any Raspberry Pi, right?
Yeah. What I'll say, this is a Raspberry Pi 3,
Okay.
3B, so you might want to get that.
Okay. Because then I can follow you through it.
Yeah, yeah.
And it's a 3-hour graduate level course. It's standalone, or it can be applied toward MBA, or it can be transferred into other programs. And it's really taking it if you are in Texas, Oklahoma, Arkansas, Louisiana,
on the Raspberry Pi itself, as well as sending it up to the serverless.
So the sensor, right, is picking up the signal from the environment, and the Raspberry Pi is the one doing the communication and sending it to the cloud.
Right, but it's sending it to the cloud, but at the same time, it's also storing the data onto the Raspberry Pi itself.
No, it's not. No, stored. No stored. Only one you stored on the Raspberry Pi was the certificate keys. You understand?
Okay.
That's the only way.
Is there a way to do that?
That's what I showed you there. I showed you that. Once you SSH once you remotely connect into the Raspberry Pi, you can now save any amount of data.